Hello, in this video we're going to go through and find the length of an unknown side to the nearest tenth, so that is 1 decimal place. So we're going to work through 2 questions here. So what I want to do first is I want to actually look at what angle is given. So I'm given 58 degrees, and then I want to make sure I label the sides relative to that angle. So if this is 58 degrees that I'm talking about here, x is going to be my opposite, and 4.2 centimeters will be my adjacent. So what I'm then recognize is that if I have the opposite and the adjacent, I'm going to use the tangent ratio. So tan of 58 degrees, and don't forget that degree sign, because if you don't write the degree sign, you're indicating that you're working in radians, is equal to x, which is the opposite, divided by 4.2, which is the adjacent. So now I'm going to actually do a little algebraic rearrangement. One thing to remember, people often get intimidated by this tan of 58. Remember, this is nothing more but a number in disguise. So don't type it in right away and then write down a couple decimal places. You want to try and keep that as tan 58 degrees as long as possible, and try and do your calculation in one step with your calculator, because that's going to mean that your answer is actually more accurate. So again, I want to get x by itself, so I'm going to multiply both sides of this equation by 4.2. So I'll get 4.2 tan of 58 degrees equals x. Now, a nice little mathematical etiquette piece is we often write the constants in front of the primary trig ratio. So I could write tan 58 degrees times 4.2, but typically we write it up front. And now I'm going to plug that in my calculator. Again, I've checked my calculator is in degrees, it's not working in radians, and we can check that by either checking the mode manually, depending on your calculator, or remembering that sine of 30 degrees is 0.5. So plug that in. I want to type this in one go. So 4.2 times tangent of 58 degrees. And so I get x, and again, this is approximate, x is approximately equal to 6.7. Now, like any math question, at the very end I want to ask myself, does this make sense? And those of you that have been watching my other videos, you've heard me say this a number of times, but remember, a nice thing about triangles, what we initially learn is that the largest angle is across from the longest side. So the hypotenuse is the longest side, and it's across from this 90-degree angle, the largest angle in the triangle, in a right-angle triangle. But the extension of that idea is largest angle is across from the largest side, and the smallest angle is across or opposite from the smallest side. So therefore, if 58 degrees, we know that is the angle here, we know that this angle will be less than 58 degrees, meaning that x should be larger than 4.2 centimeters. Let's do this next question. I'm going to work in pink now, just to mix it up. So this is the angle that I'm working with. So y is the opposite, and 3.8 is the adjacent. So we know tan of 15 degrees is equal to the opposite, which is y, over the adjacent, which is 3.8. I'll just plug this in my calculator now. Well, not quite yet. 3.8 tan of 15 degrees is equal to y. So y is approximately equal to, and again, before I even type in the answer, I'm expecting a value less than 3.8. So 3.8 times tan of 15 degrees, approximately 1.0. Okay? Let's do one more question, shall we? Okay, let's try this question here. Now this question is a little bit different, because notice, again, if I'm given the angle 41 degrees here, 8.7 is the opposite. This is a little thick, I think. Let's go up a little bit more. Let's pick a thinner marker. There we go. 8.7 is the opposite. K is the adjacent. So in this case, if I set this up, tan of 41 degrees, don't forget that degree symbol, is the opposite, which is 8.7 divided by k. So in this case, notice it's not as easy to isolate. It's not tricky once you get the hang of it, but not as easy. Now a little point of order. Some people learn these fancy triangles. It's kind of like your speed, distance, time triangles that they use. And if you don't know what I'm talking about in terms of trigonometry, that's good, because often students will memorize these triangles to help them figure out the algebra here. I really want to stress, just learn the algebraic manipulation. Okay? Algebraic manipulation, if you put the time in now, it's going to pay off in a lot of your work that you do moving forward. Okay. So remember, tan 41 degrees is just a number, so we can treat it just like a number. So I'm going to multiply both sides by k first, and what that is going to do is we're going to end up with this. Now then students often scratch their head and they say, well, what do I do with this tan 41 degrees? Now I'm going to draw a little intermediate step. I typically wouldn't write here, but if tan of 41 degrees is simply a number, I can divide both sides by tan of 41 degrees. And those are going to cancel out. And of course, if I divide one side by tan of 41, I have to divide the other side by tan of 41 degrees. And I get k is equal to 8.7 divided by tan of 41 degrees. So k is approximately equal to, and let's type this in, 8.7 divided by tan of 41 degrees. Close my brackets, and I get approximately 10 units, or in this case, 10 centimeters, which I feel good about, because if this is 41 degrees, this angle here will be larger, and therefore k will be larger than 8.7. And in fact, I feel even better about it because 41 degrees, these angles will be pretty close, meaning these sides are going to be pretty close in length. I hope this video helped.